Hello, everybody, and welcome to the Everything Technology Podcast. I'm Bob O'Donnell, the host of the podcast, as well as the President and Chief Analyst at Technalysis Research. So this Everything Technology Podcast, it's all about analyzing the tech news as well as talking to tech industry leaders about important topics. And boy, this past week we had a lot of both. Lots of news I'm going to get to. And also, I'm excited to share that the guest on this week's program is Dr. Tingfang Ji, and he is the Senior Director of Engineering at Qualcomm. And we're going to be talking about one of my favorite topics, 5G. And we've got a lot to talk about, really getting into the details about the transition to 5G, some of the challenges that are facing, and some of the opportunities still ahead of us. But first, let's get to the news. Well, here we are, mid-September, and the tech industry news cycle has kicked off with a fury. Boy, I have to tell you, this was one of the busiest past weeks I've had in an extraordinarily long time. There was a huge amount of events, a lot of stuff. Try to get to as much of it as I can. I'm going to try and cover as much of it as I can for this week's podcast. We'll just do it sort of in chronological order. Zoom had their big Zoomtopia last week. That's their annual event. You know, it's hard to realize Zoom is 10 years old. 10. Right? I mean, it feels like they just came on the scene in the pandemic, but they've been around for a long time. And of course, it's the pandemic that's made them a household name, literally. And they continue to build on their platform. You know, in fact, what was interesting, and I'll talk a little bit about Cisco later in the podcast as well, but we're seeing all of these companies creating not just video calling tools, right? We've actually had those for a while. What we're creating is video messaging and collaboration platforms. And platforms implies with it additional software and capabilities on top of a baseline. And that's exactly what Zoom did at Zoomtopia this past week. They had a number of new additions that they talked about. They've got a new whiteboard app. They've got Zoom calling with video voicemail. They have new conferencing tools that allow you to create an entire conference with all the things associated with that, including email and everything else. They're starting to integrate chat into it, not only their own chat, of course, but actually allowing the chat from some of the other platforms like WebEx and Teams to be integrated. Now, it's a long way from integrating all the other elements as we've started to see, and I think we're going to see a lot more of that moving forward, but still definitely interesting to see Zoom getting a little bit more involved with that notion of integration, because realistically, that's what we all need moving forward. You've got to have the ability to have all these systems interoperate. It's absolutely essential for that to happen. And Zoom didn't really get there, but of course they built out their platform. The other interesting thing, got a lot of attention, we'll see if it actually gets a lot of use, was Zoom talked about a collaboration with Facebook, specifically with Oculus, for the Oculus headset, so that you could actually do a VR Zoom call, which is kind of crazy. But basically, you can use the VR capabilities of the Oculus headset and then some of the Zoom collaboration tools to have a meeting, VR style. Remains to be seen how effective that actually is, but it's an interesting concept, and it shows you the way that people are thinking about things. So certainly something to be aware of. Of course, the big consumer tech news of past week was the Apple event, the California streaming event, where we saw the company unveil a number of things that were expected and a couple things that weren't, actually, and I'll get to that in a second. Of course, what everybody expected and what did come out was the new iPhone 13, the whole line of iPhone 13. It's got new colors. It's got a new A15 Bionic chip. It's got enhancements to the camera. You know, the reality is, purely technically speaking, there's not a huge advance over the iPhone 12. Of course, it has 5G. It's the second generation iPhone with 5G. That's important. And, you know, some of the other specs are nice. They've got higher refresh rates on especially the Pro and the Pro Max, and a variable refresh rate. That's actually kind of cool because one of the problems, if you move to 120 hertz, which it gives you a super smooth kind of experience, which Samsung has had on the Galaxy Fold 3, on the S21 Ultra, a couple other phones, as well as a few other companies. It does take a lot of battery. And so adaptive refresh, ProMotion as Apple calls it, lets you have the ability to get a fast refresh when you need it for games, for things like that, but it'll slow it down when you're not, the refresh rate that is, without any it's completely imperceptible, but it impacts how much battery use there is, and that's an important step. So that's big news. And then, of course, lots of fantastic cinematographic, whatever that word is. Anyway, you can take incredible videos with it. That's the deal. And they really showed that off. And you have to admit, some of these things have been incremental, but think 5 years ago to now, and what you can do on a smartphone, the quality that you can create. Apple now can do, this ProRes video format from shooting to editing, and to playback. It's pretty amazing if you think about it. Again, some other folks have had high-res capabilities as well, but, Apple puts it all together. And by the way, if we learn nothing else from this last Apple event, they are so good at marketing. They made everything feel incredibly new and special, even if it necessarily wasn't. One thing that was new and special, however, was the iPad mini. Nobody expected iPads at this event. Everybody's been thinking, this one's going to be phone and watch. And of course, we did have Watch Series 7. I'll talk about that in a second. But nobody expected minis and, of course, no new Macs. Well, there were no new Macs. And by the way, there were also no new AirPods, which some people thought there was going to be. But there was a new iPad mini. And at first you're thinking, gosh, iPad mini, come on, old news, right? We got foldable phones with screens almost that big. But I have to say, pretty impressive. It's a technological powerhouse there. Had a 5G option available, high resolution screen, a lot of capabilities there. Now, not cheap, $499, but a super nice extra gadget device for folks who want to have something that they can take with them. It's definitely not going to replace anything else that you have. It's an additional device. But in a lot of ways, I think the iPad mini was kind of the star of the show, which is definitely a surprise. Onto the Watch 7. It had been expected, although the rumors of it being, sort of square and having more of an iPhone-like look were not at all true. In fact, now there's rumors saying that the false rumors were designed to figure out who from Apple's leaking the other stuff. We'll see if that actually happens. But anyway, Watch Series 7 does have a bigger display. And if you look at the specs, it's very modest. But when you actually saw how much more, for example, text you could see in a text message on the Series 7 versus the Series 6, it was actually kind of impressive. So interesting to see how the Watch Series 7 does. No big new sensors, that some people were hoping for. That'll have to take till the next generation. And Apple certainly didn't have any AR or VR or car stuff as part of this event. All those things are perhaps coming down the road. But nevertheless, a great job as always by Apple. Speaking of car things, though, there was some interesting car tech-related news. In this case, it came from ARM. ARM, of course, is the company that designs the IP, the intellectual property, for the chips that are inside the iPhone. The ARM is Apple licenses ARM. Everybody licenses ARM for smartphones. And, of course, increasingly now, Apple's doing it for Macs. We've got it server chips from companies like AWS, from Amazon, lots of other places. So the ARM architecture, is becoming extraordinarily important. And one of the things that has been a huge part of ARM's business for a long time has been the automotive market. And they have, if you never knew this, A, R, and M series. M is microcontrollers, the super small devices. R is real-time chips. And A are the A series SoCs, is what you see used as the core, for example, for the A15 Bionic and Samsung's chips and Qualcomm 888 and all that kind of stuff use the A architecture. Anyway, cars have all three of those. And cars, of course, are increasingly being digitized and what have you. The challenge that's happened in the automotive market is that car makers are not tech companies and tech companies are not car makers. Tesla tries to branch between the two, and we could argue, obviously there are a lot of Tesla fans who are going to say, of course they are. But we haven't seen the Apple car, for example. We haven't seen super innovations on the automotive makers on the tech side. Part of the problem is every car maker is having to essentially start over and create everything from scratch. And that has really slowed the development. So ARM has created an open standard called SOAFEE. It stands for Scalable Open Architecture for Embedded Edge, which implies more than just cars, but they're focused on cars for now. And the important thing about it, it's an open standard. They've created a SIG, a special interest group, with a bunch of folks involved in the auto industry, what are called the tier one folks who help car makers. Continental, another company that's associated with Volkswagen as part of it. They're the ones that build major subcomponents, subsystems of a car, and then provide them to the car makers. Anyway, a whole bunch of companies are involved with this SIG. The idea is to have an open standard that can be reusable. It's open source, so that companies can leverage the work that others have done. And ARM created, along with Ampere, which is a ARM chip company, and another company making boards that allows you to create reference designs, either in the lab or in the car, to test your ARM-based software. It's a multi-year effort. It's a big step forward, so it's interesting to see. And I wrote about it. If you're interested, I'll have a link below. I wrote about it for my column last week that's on LinkedIn, TechSpot, and Seeking Alpha. In other embedded news, Silicon Labs, they're a company not a lot of people may be familiar with, but they've been involved with smart home and a bunch of other areas. They had an event called Works With, and it was designed to bring together a whole bunch of folks in the chip industry who are working towards, and in the smart home and industrial automation industries, working on essentially making IoT happen. So Sophie is sort of an IoT version of a device when we think about a connected car. Silicon Labs works with a whole bunch of folks on a number of areas, including the Matter protocol. Matter is something we're going to hear a lot more about over the next year or two. Matter is a new industry standard protocol. I know there's a million of them, but this one seems to be really getting traction with Google, with Amazon, with Apple, with all the big players in smart home, as well as people like Schneider Electric on the industrial side. So lots of chatter about Matter, pardon the pun, at the Works With conference. They also unveiled, Silicon Labs unveiled a ZG23 and another line of RF chips that can actually go up to 1 mile in terms of their transmission rates. They're using sub-gigahertz frequencies to do this. And they can provide up to 10 years of battery life. They can support a design that has 10 years of battery life on their own. So what's interesting is what this implies, and why it's important, is it talks about the fact that, we always hear about Wi-Fi and Bluetooth and 5G, but there are other ways to communicate wirelessly. And Amazon Sidewalk, for example, Silicon Labs is targeting sidewalk-based devices, what have you, is another mechanism for connecting a whole bunch of other components and devices. And there are other people working on different standards as well to do wide area wireless network connections. So that's going to be important. Another big thing, of course, that's also very important is the issue around chip shortages. And there's no easy answer to this, but there was an interesting discussion on chip shortages and how to address that. And what we're seeing is companies have to be creative. They're creating new designs with the chips that are available. They're jumping on chips. If a company makes a decision to move to a different design, they're jumping on whatever's available to try and figure it out. They're getting smarter and communicating more across the industry. All little steps to try and help deal with the fact that we're not going to have the chips we need for a lot of different devices, probably for a couple of years. Yes, companies are building more chips, and in fact, I'm going to talk about that in a second, but it's still going to take several years before we see all of that. Speaking of chip makers, GlobalFoundries, one of the world's largest chip makers, not as well known, but they do have a number of foundries here in the U.S. They had their annual technology summit event this past week. And what's interesting about GlobalFoundries is they don't pursue, you hear about the 4 and 5 nanometer and 7 nanometer parts that you see TSMC and Samsung and some other of these chip makers make. GlobalFoundries made a rather controversial decision a couple of years ago to focus on larger chips, what are called the legacy chips, which, by the way, is a huge part of the challenge that the auto industry has, is not enough people make those older chips, 12 nanometer and higher, 28 nanometer, even much older, and what are called larger process geometries. Anyway, GlobalFoundries recently announced that they're going to be building more capacity for these older process technologies. But not just that, but the other thing that GlobalFoundries does is they have a number of very specialized capabilities, and they talked more about some of the new ones they have. And in particular, it turns out certain kinds of chips actually not only aren't any better, they're actually worse when you try and go to smaller sizes because of things like leakage and other problems. So chips like RF front ends, these are really critical components for 5G devices of all kinds, modems, smartphones, anything that has a connection with radio frequencies, including even those low bandwidth ones I was just talking about from Silicon Labs. All of those things benefit from being able to have good process technologies that allow low leakage and higher signal quality. And that's what GlobalFoundries focuses on. They talked more about that at their event. And not surprisingly, they had an announcement with Qualcomm. Qualcomm, of course, is one of the world leaders in 5G modems, but also in RF front ends. And GlobalFoundries also had Qorvo there, another big company makes RF front ends and filters and other little niggly detail chips that are critically important to make all this 5G stuff work. Anyway, bottom line is now GlobalFoundries and Qualcomm are going to be working together. Even they have been, but they extended that agreement to work further to extend RF front end development, which is going to make all of our 5G phones better and faster. And that's always a good thing. And then the last thing I wanted to get to, speaking of 5G, was Cisco had their both an investor and an analyst day. And they talked about a number of areas where the company continues to evolve. One of them is 5G infrastructure. They talked about how they work extensively, for example, with Rakuten in Japan. Rakuten is a standalone company, is a company creating a completely software-defined 5G network in Japan. We're going to see Dish do something similar here in the US. So throughout the various events that Cisco had, they emphasized that, look, yes, we're doing some of the switches and routers that we're known for this, but a lot of what we're doing is actually software. And they talked about how they are evolving and their revenue in software, for example, has quadrupled over the last couple of years. And they're doing software for things like WebEx for hybrid work and collaboration, hybrid cloud, the ability to see how applications work across a hybrid cloud. All of these things are critically important. And that's what they talked about and emphasized that they are evolving and they need to be thought of in a different way. All right. Lots of stuff to cover right now. Now, speaking of 5G, super excited. We're going to switch over here in just a second to the interview portion of the podcast. And again, my guest is Dr. Tingfang Ji, who's the Senior Director of Engineering at Qualcomm Technologies. And we're going to go in great detail about 5G and its evolution. So stick around. Hello, everybody, and welcome back. I'm Bob O'Donnell, the host of the Everything Technology podcast. And now for the interview portion of this week's podcast, I'm happy to have Tingfang Ji. He's a Senior Director of Engineering at Qualcomm. And we're going to talk about one of my favorite topics, 5G. So Tingfang, first of all, I want to give everybody a little bit of an introduction to yourself. I understand you have quite a few patents there at Qualcomm around 5G. So tell us about your history, how you got into all of this, and some of the work that you're doing.
Thank you, Bob. It's really a pleasure to be on your show. Yes, I've been with Qualcomm for almost 20 years, I think 18 years and counting. And I started working on 4G LTE, and we even went to the standards bodies, which defines the 4G LTE protocol. Worked there for almost 10 years. And then we started the 5G project. So yeah, so this is.
And when was that, by the way? How long ago did you start the 5G work?
The 5G work we started about 2014. So
Wow.
It's just amazing. It's amazing, right? From having nothing, just have a concept of we're trying to define what should we accomplish in 5G. To today, actually, hundreds of operators and hundreds of millions or billions of devices now have 5G. So it's a really amazing journey.
So I'm curious, can you give us a little sense of what the original goals for 5G are and how they've changed, or if they've changed since then? Because I'm sure there's got to have been some adjustments over time.
Absolutely. So when we started looking at 5G, there are these traditional key performance indicators. We call it KPIs. So
Sure.
like typically say how much is the bandwidth, what is the throughput. So those are the big ticket items that we're trying to accomplish, right? And then we think about the use case to map those metrics into is something called the mobile broadband, which is pretty much a smartphone. And
Yep.
then we have this mission critical type of application we call ultra reliable low latency communications. And then we have this massive
LLC.
URLLC, exactly.
Right.
Then we have this massive Internet of Things. It's IoT applications. So in some sense, I think our vision at that time to target these three type of drastically different use case is still holding. And right now, 5G is adopted, I think, very broadly already for the EMBB, enhanced mobile broadband applications for smartphones.
Right.
We're still waiting for the other two bigger use case to take in. Actually, we did some market analysis, I think a couple of years ago, which is predicting about $2-3 trillion of market worth of digital economy of 5G in terms of this enhanced mobile broadband. But there are about 10 billion more that's left in terms of massive Internet of Things and these mission critical URLLC type of applications. So I think 5G is just starting. We really still have a long runway before we can reach the original vision that we had for 5G design.
So I want to go in two different directions. First, to follow up on the applications. What do you think are the reasons for URLLC and the massive IoT to be somewhat slower? I'm just kind of curious.
That's a very good question, right? We're also asking ourselves. I think one of the clear distinction is a lot of these applications are not facing consumer, which the operators, they are really smart, really good at developing new services for the consumers, right? On smartphone, on your laptop, all these use cases. So they once you give them the tools, the new 5G, toolbox, they can quickly hammer out all different services. But the massive IoT and URLLC type of services are more facing business. So I think the operators, they are doing a great job in terms of ramping up those services, developing those new applications. But it will take some time. It's not just taking what we have in 4G and just recast it in 5G. They need to be innovative. Now they have a big hammer. They are looking for the nails. There, but it's not like the smartphone is a big target. You can just bullseye. You can hit it. Here, there are hundreds of different areas you need to actually customize. You need to apply the technology to. So it will take some time, but I'm very confident that it's going to happen and can't wait for it.
Fair enough. So, and that leads to that second question where I wanted to go back to the development of some of the core technologies. So as you were developing those technologies, obviously some of the core capabilities are going to be necessary for all three types of applications, but I'm sure some were much more targeted at one or the other. What were the sorts of things that you specifically had to do, for example, for massive IoT or for URLLC from a base sort of technology and patent type perspective?
The fundamental technology for URLLC, as you can see in the acronym, is reliability, and low latency, right? Those things human can perceive to some extent, right? So when you loading a web page or download a movie, you can perceive the latency. But typically, human perception is on the order of hundreds of milliseconds, or even when you play a game, right? But for these industrial applications and for smart grid and these critical communications, they can perceive latency on the order of milliseconds. So that will require fundamental new designs so that the turnaround time, you're no longer just optimized for gigabits per second, but rather you're going to say that I have a sort of a three tuple of things I want to achieve at the same time. First, of course, the bandwidth you need to be able to deliver. The second is reliability. This data has to be 99.9999% reliable. And the third is, hey, this data will be useless actually after 3 milliseconds. So now when we design the technology, we need to couple them together when we actually send a packet or when we send some sensing data. So those are fundamental designs you bake into the technology. So that's just one example for URLC. For massive IoT, on the other hand, sorry, Bob, is just let me elaborate a little bit, is massive IoT, the metric is more about saving power and scalability. So how do you minimize the power consumption for these IoT devices, which might have to last for 5-10 years without a charge, right? So, and also there will be a lot more of them compared to smartphones. So again, there the scalability and low power are fundamental technologies that we have been designing for.
And yet some of those core technologies theoretically cross over, right? I mean, there's been a lot of talk about latency, for example, in a smartphone application such as cloud-based gaming. That's the classic one. They're like, everybody wants, those super low latency times. Can we think about it the same way? Is it fair to say that the latency that was designed for URLLC is the same kind of latency we can expect in a smartphone application, or are they totally different animals?
That's a very good analogy, actually. I think there are a lot of commonality. I'll say the technology is probably 80% common, but there are additional extra sauce that you need to put in for the URLLC type of application, because latency is a complicated beast, right? So latency, we typically talk about end to end. So what that means is it's not only just over the air portion of when the waveform, right, a packet is transmitted from a modem to another modem. Actually, it's end to end. You need to cross application layer, right? And then you get into the modem and then cross the air, and then you run through this in the radio area network, the operator's network, then run over internet, then go to the application again. So for smartphone, in some sense, even for edge applications, typically the stack you can tolerate. If suppose you have 20 millisecond or 50 millisecond of budget, you could allocate latency in different blocks. But if you want to achieve, say, something within 5 milliseconds, then the optimization is not only for the over-the-air portion, but you also need to change the network topology. You actually have to bring some of these applications to the edge of the network, actually, for example, inside the factory. So from the over-the-air portion, they might look similar. You can have similar techniques in terms of multiplexing, in terms of scheduling, and these very interesting algorithms. But also network architecture needs to change. So that's probably the biggest difference.
And it's very interesting because one of the things that I think people are starting to see is that I mean, admittedly, obviously still early days for 5G, but simply speeding up, network transfer of packets is okay. I mean, nobody's going to complain about that, but it's not really enabling, these kind of big new, like you said, applications in the business world. And I think there's more and more recognition of the importance of putting some of those compute elements on the edge, and it's that combination of 5G plus the edge that really gives you something new and different. Is that a fair way to think about it?
Absolutely. I think that's a new direction. That's where Qualcomm is going. So we're not only just making the devices, actually Qualcomm in our research and development, we're really targeting this wireless edge. So that's where you could solve the holistic problem. The end-to-end problem has to be solved with a big innovation on the wireless edge. So yeah, it's a very good point you're making.
And the other thing I want to dive into related to all of this and how it impacts performance and some of perhaps the core technologies is when we think about 5G, one of the things that's different, of course, is that to make the transition easier, there was the creation of non-standalone mode and then, of course, standalone mode. And I think a lot of people get confused about it, myself included sometimes, of really understanding the importance and the difference between them and what does standalone mean? And is that over the air or is it in the inside of the network? And I'd love to get a little bit more insight around that and some of the key technologies that are involved with that.
Yeah, standalone and non-standalone was actually a terminology we invented around, I think, 2017. In the sense of when you deploy a 5G network, you have a choice of taking the core network and the basic coverage of LTE, 4G, and then add 5G on top. So that network is called non-standalone because you are actually connecting to the 4G core network, the backbone. And also you're using 4G to sort of manage mobility, reliability, and many other things. And the standalone is a deployment where you're saying that, hey, not only I want to update the over-the-air, network, it's a change from 20 megahertz to 100 megahertz and reduce the latency, but also I want to change the architecture. And I also want to run this independently, so I'm not bottlenecked by the 4G side of latency and limitation. So standalone network is sort of more greenfield-ish. Is you can deploy this without a backbone of 4G network. I think both of them have their use cases, depending on each operator's trade-off they have to make in terms of investment. Do they want to upgrade the over-the-air portion first, or they also want to upgrade their core network at the same time? They have all these different toolboxes, and I think standalone network will clearly also enable new services because some of the services are limited by what you implement in the core network.
Yeah, and it's interesting because I think like I said, one of the things I sometimes get a little bit confused about is what in the core network changes. Like, is it the compute capabilities? Is it the wires interconnecting? Is it a combination of all of them? What exactly changes when you go from non-standalone in the core, from a 4G core to a 5G core, essentially? What changes there? Because it's not the radio signaling that's already happened before it hits the network. So how does the core network change from 4G to 5G?
I think the change is actually quite a bit. So there are many different areas. The most obvious one is quality of service. So these new type of services, they are typically, you could introduce them to legacy network. But typically they are not. So the new services, say what you want the XR, you want the AR, VR, these augmented reality services, they need to be defined in the 5G core network. Simply, when you ride over the 4G, those type of quality of service in terms of latency, throughput, reliability, jitter, these things doesn't exist over there. So that's something that's brand new that's introduced. Secondly, I think 5G architecture is different from 4G, where you actually are splitting some of the functionalities that's a single box in 4G into multiple different boxes. And now you have the flexibility of actually implementing them separately. So this one I can take from one vendor, and the other functionality I can actually run it on in the cloud, for example. And also you can change their topology. Say now I split the functionality. Now I can actually drop this functionality, some of them to the edge, and sometimes I keep them deep in the network, depending on the deployment scenarios. traffic need. So the core network offer you that flexibility in terms of trade-off as well. The network slicing is something you will often hear is I provision a slice of the network for a new service. So those are the very powerful tools that 5G is introducing.
Got it. Makes perfect sense. Well, amazingly enough, we've come to our time already. Tingfang, thank you so much. Any final thoughts? What do you think will be the next thing that we'll see in 5G that people will feel will make an impact?
Bob, that's a big question, and we are all debating it. Actually, the next release of 5G currently is being actively discussed. We call it the 5G and the 5G Advanced. So we're almost done with the first 3 releases of 5G standards, and the next 3 releases is being as 5G Advanced. The topics that we're currently discussing is not necessarily a sure thing to happen yet. Is, for example, machine learning. So you can not only implement machine learning in the modem, in the network, on your phone for applications, but can you use machine learning to enhance the protocol itself? Can the area interface itself use machine learning to adapt to new use cases and getting advances? Another one is a full duplex radio. So instead of having transmission and reception on different frequency, so now you can actually do them at the same time. So quite a few of big technologies being discussed right now. So
sounds good. Well, hey, Tingfang Ji, again, Senior Director of Engineering at Qualcomm, thank you so much for joining the podcast. I greatly appreciate it. And best of luck keeping pushing that 5G standard forward.
Thank you, Bob. Hope to talk to you again.
All righty. Take care. Thanks so much.
Okay. Bye-bye.
Thanks so much for tuning into the Everything Technology podcast. I look forward to speaking to you again soon. Take care. Bye-bye.